Hello everyone, myself Sachin Gaware from RBNB College, Shrampur. Today we continue our chapter from 12th Science Mathematics Probability Distribution. Now the next point from this chapter is expected value and variance of a random variable. Now to define the expected value and variance of a random variable, let's consider a probability distribution. The probability distribution for an random variable x. The probability distribution for an random variable x in tabular form, in which we represent the random variable x. Let random variable x takes the value x1, x2, x3 and so on, suppose xn. These are the values of an random variable x, and with corresponding probabilities p1, p2, p3 and so on pn. If this is the probability distribution for a random variable x, then the expected value or the arithmetic mean, the expected value or the arithmetic mean of this random variable x is denoted by mu or e of x. Mu or e of x, and it is given by summation of xi into pi, where I runs from 1 to n, where I runs from 1 to n. This is the formula for arithmetic mean or expected value of a random variable x. Similarly, we define the variance. Similarly, we define the variance of a random variable x, which is denoted by VAR of x, or simply by sigma square. Simply by sigma square, and it is given by the formula summation pi xi square minus this expected value mu square, minus expected value mu square, where this summation again runs from 1 to n. This summation again runs from 1 to n. Here these are the two formulas which we used to find an expected value and variance of an random variable. Again I repeat, the expected value, or which is called as arithmetic mean, which is denoted by mu or e of x, capital E of x, and which is given by summation xi pi, summation over I runs from 1 to n. And similarly the variance which is denoted by sigma square, it is given by summation pi xi square minus expected value, that is mu square. That is mu square. Now, depending on this expected value and variance of a random variable, we continue some problems from exercise 7.1. We continue some problems which are from exercise 7.1. Now, the problem number 9 is Now see the problem number 9 from exercise 7.1. Find the expected value and variance for the following PMF. That is, here we have given the PMF, that is probability mass function, and we have to find the expected value and variance. Now we know that the formula for expected value E of x, or we denote it by simply mu, which is equals to summation pi into xi, summation pi into xi, or you can say summation xi into pi. Now that is, take the product of value of random variable x and its corresponding probability and make it sum. So putting these values from this summation product, so this can be written as -2 into 0.2 value of x1 into p1 plus -1 into 0.3 plus 0 into 0.1 plus 1 into 0.15 and plus 2 into 0.25. 2 into 0.25. Now taking this product, this becomes -0.4. 2 into 0.2 means 0.4, negative sign. Here again plus minus becomes -0.3. 0 into 0.1 means 0, plus 1 into 0.15 means again 0.15, and plus 2 into 0.25, 2 into 0.25, that is 0.5. It becomes 0.50, or you can say 0.5. So it becomes this 0.15 plus 0.5 becomes 0.65 minus this 0.4 minus 0.4 minus 0.3 becomes minus 0.7. And so after taking this subtraction, we get expected value, that is mu equals to minus 0.05. We get minus 0.05. This is the value of expected value. Now to find the variance of this random variable x, we know that the formula for variance of x, which is also denoted by sigma square, it is given by summation xi square into pi minus mu square, that is the expected value square. Now putting these values, so first to write the summation of product, so here xi square into pi, so it becomes -2 into 0.2, so -2 square xi square into pi means 0.2 plus -1 square into 0.3 plus 0 square into 0.1 plus 1 square into 0.15 and lastly plus 2 square into 0.25 and minus this mu. The value of mu is here minus 0.05, so it becomes minus 0.05 its square. Now making this calculation, the -2 square is 4, so it becomes 4 into 0.2 plus 1 into 0.3 plus 0 into 0.1 means 0 plus 1 square means 1, 1 into 0.15 means 0.15 and lastly 2 square means 4 into 0.25 and minus, now the square of 0.05 minus 0.05 is 0.0025. The square of negative number is positive, so it becomes minus 0.0025. Now, making these calculations, 4 into 0.2 means 0.8 plus 0.3 plus 0.15, this 0.15, and plus 4 into 0.25 means 1. So it becomes a plus 1 minus 0.0025. Now taking this sum, this 0.8 plus 0.3 means 1.2. 1.2 plus 0.15 means 1.25 plus this one, so it becomes 2.25 minus 0.0025. 0025. Now make this subtraction. Now to take this subtraction, this can be written as 2.2500. This 2.25 can be written as 2.2500 minus 0.0025. Now take this subtraction. Now when we take this subtraction, it becomes 10 minus 5 means 5. 10 minus 3 means 7. 5 minus 1, 4. 2 and this 2. So finally the variance, that is the sigma square, becomes 2.2475. It becomes 2.2475. This is the variance of an random variable x. Now we see the next example, example number 10. Now see the example number 10. Find the expected value and variance of x where x is the number obtained on uppermost face when a fair die is tossed. Now first we have to write here the probability distribution. Now we know that when we toss a fair die, its sample space is 1, 2, 3, 4, 5 and 6. And here x is defined as that x is the number obtained on uppermost face. So here the values of x are again 1, 2, 3, 4, 5 and the 6. And so the probability distribution that random variable x takes the values 1, 2, 3, 4, 5 and 6 is, suppose here it is, the probabilities are pi. Now there are total 6 outcomes. From that 6 outcome, one appears once only. So the probability that random variable x getting the value of 1 is 1 upon 6. Similarly, the probability that x gets the value 2 is 1 upon 6, for 3 1 by 6, for 4 1 by 6 and 5 1 by 6, for 6 it is 1 by 6. This is the probability distribution for an random variable x where x is the number obtained on uppermost face of an die. Now here we have to find the expected value and variance for this probability distribution now. Now again we know that the formula for expected value, which is also denoted by mu, is summation pi into xi or xi into pi. Now putting these values, now the values of xi are 1 to 6 and the probability is fixed 1 by 6. So it becomes 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 and plus 6 into 1 by 6. Now taking this 1 by 6 common from each term, taking 1 by 6 as a common factor, so the remaining terms are 1 plus 2 plus 3 plus 4 plus 5 and plus 6 into 1 by 6, the common factor. Now take the addition. Now 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 10, plus 5 15 and plus 6 21. So it becomes 21 upon 6, that can be written as 7 upon 2 dividing by 3, after dividing by 3. So we get the expected value, or say mu, equals to 7 upon 2. Now next, to find the variance, we know that the formula for variance, or which can be denoted by sigma square, this is equals to summation pi xi square minus mu square. Now again putting the values, this can be written as 1 square, that is the value of first value of x, 1 square into 1 by 6 plus 2 square into 1 by 6 plus 3 square into 1 by 6 plus 4 square into 1 by 6 plus 5 square into 1 by 6 and plus 6 square into 1 by 6. See here, the values of x are 1, 2, 3, 4, 5, 6, and the probability each time is 1 by 6. So we write here 1 square into 1 by 6, 2 square into 1 by 6, and so on, 6 square into 1 by 6. Now minus mu square. Now the value of mu is 7 by 2. So here we write minus 7 by 2 square. That is the expected value, square. Now again, take 1 by 6 as a common factor. Take 1 by 6 as a common factor. So it gives 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square into 1 by 6 and minus, now the 7 upon 2 bracket square is 49 upon 4. It is 49 upon 4. Now taking these squares, now if we take these squares, this can be written as, now that next step can be written as 1 square means 1 plus 2 square 4 plus 3 square 9 plus 4 square 16, 5 square 25 and plus 6 square 36 into 1 upon 6 and minus that term, that is 49 upon 4. 49 upon 4. Now take this summation. Now take this summation. Now if we add this one, this becomes 1 plus 4 5, 5 plus 9 14, 14 plus 16, that is 30. 30 plus this 50 becomes 30 plus this 50 becomes 80 and plus this 11 it becomes again see here 1 plus 4 5, 5 plus 9 14, 14 plus 16 30, 30 plus this 50 becomes 80 and plus this 11 that becomes 91. So it becomes 91 upon 6 minus 49 upon 4. Now take the LCM. Take the LCM of 6 and 4. So the LCM becomes 12. So make the denominator 12. So it becomes 91 into 2 and minus 49 into 3 divided by 12. Now taking this product, this becomes 182 minus 147 upon 12. 182 minus 147 upon 12. Now take this subtraction. Now it becomes 35 upon 12. This becomes 35 upon 12, and therefore this is the value of variance of x, or you can say it is sigma square. It is sigma square. Now one alternate method is to find this summation, that is 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square. You can use the method of induction or binomial theorem, which gives the sum of first n natural number. The sum of first n natural number, that is 1 square plus 2 square plus 3 square and so on plus n square. This becomes n into n plus 1 into 2n plus 1 upon 6. You can use this formula also. Here the n is 6. We take here the sum of squares from 1 to 6. That is, the n is the 6. So if we put here n equals to 6, for n equals to 6, this becomes 6 into 7 plus into 13 upon 6. This 6 gets cancelled. And finally, 7 into 13, that is 91. This sum is 91 appears here. So to take this addition directly, or you can use the binomial method of induction, standard formulas. So here we get the finally variance sigma square equals to 35 upon 12. Now for next problem, now the next problem is find the mean number of heads in 3 tosses of a fair coin. Now we know that the sample space for tossing 3 coins or 3 toss of a coin, the sample space is S equals to HHH, then HHT, HTH, THH, then TTT, TTH, THT, HTT. These are the 8 outcomes. 1, 2, 3, 4, 5, 6, 7, 8 outcomes for tossing a coin 3 times. That is, n of s is 8. Now here we define the random variable x as number of heads. Here we define and random variable x as number of heads. So right here x equals to number of heads. So here the minimum and maximum number of heads, that is the values of x, are 0, 1 or 2 only. It is 0, 1 or 2 only. Now to write the probability distribution, see here the probability distribution for getting head in tosses of 3 coins, we get x and pi's. that is corresponding probabilities. The value of random variable x are 0, 1 and 2. Now the number of elements in which there are 0 heads, such only one outcome is exist. So for x equals to 0, the probability is 1 by 8. Now for x equals to 1, that is getting one head, there are 3 elements or 3 outcomes. So the probability for x equals to 1 is 3 by 8. And for x equals to 2, again it is probability for 3 by 8. And one more outcome, that is the value of x is 3. So we consider here that is the getting 3 heads. Now there exists only one outcomes. Only one outcomes where 3 heads are exist. So for x equals to 3, the probability is 1 by 8. This is the probability distribution for getting number of heads in toss of a coin 3 times. Now to find the expected value or mean value, remember one thing, mean value is nothing but the expected value. Mean value is nothing but the expected value. So we find the expected value E of x equals to mu. Its formula is summation of pi into xi. Summation over I. Summation over I. Now take this product. Now 0 into 1 by 8. 0 into 1 by 8 plus 1 into 3 by 8 plus 2 into next product 2 into 3 by 8 and last one is plus 3 into 1 by 8. Now taking this product, it becomes 0 plus 3 by 8 plus 4 by 8 plus 3 by 8. Now taking the addition, it becomes 3 plus 4, 7, 7 plus 3, that is 10 by 8. The product is 10 by 8, that is 5 by 4. That is 5 by 4. So we get the expected value, or you can say mu, or simply mean for an random variable x, which is equals to number of heads, equals to 5 by 4. Now the next example. Now the next example is 2 discs are thrown simultaneously. Then we have to find the expected value where x is the number of sixes. Now we know that when we toss the 2 discs, there are 36 outcomes. There are 36 outcomes which are 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Then next 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Next 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Next 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, and next one is 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. These are the 36 outcomes when we toss the 2 dice. So here n of s equals to 36. Now if we define x is number of sixes, that is here, right, x equals to number of sixes, number of 6s, and therefore in these outcomes minimum 0, 6 is available and maximum 2, 6 is available. So the number of 6s, that is x takes the value 0, 1 or 2. 0, 1 or 2. Now to write this probability distribution, we can write here the values of x and corresponding probabilities pi, that is the value of x are 0, 1 and 2. Now observing this sample space, there are 25 outcomes. These are the 25 outcomes in which there is 0, 6 is appear. The 25 outcomes in which 0, 6 is appear. So the probability for x equals to 0 is 25 upon 36. Similarly, there are 10, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 outcomes in which 1, 6 is exist. So the probability for x equals to 1 is 10 upon 36. And lastly, there exists only one element in which 2, 6 are appear. So for x equals to 2, the probability is 1 upon 36. Now this is the probability distribution. Now we have to find the expected value. Now we have the formula, expected value E of x, that is equals to mu is summation pi into xi summation over I. Now putting these values, we get 0 into 25 upon 36 plus 1 into 10 upon 36 plus 2 into 1 upon 36. So it becomes 10 upon 36 plus 2 upon 36. That gives 12 upon 36. That is 1 by 3. That is 1 by 3. So we get the expected value of x equals to 1 by 3. Expected value of x is 1 by 3. Okay. Thank you. We will stop here.